If you're wondering where to start with your solar exploration process, the Energy Trust of Oregon has a website that's a very good resource. You can go on there and fill out a form, and they will put you in touch with 3 solar contractors that are trade allies of their solar program, just like SunPath Services. They'll send your information out to those contractors, and they will send you quotes, typically over email before a site visit. That'll get you started. You'll have some numbers to look at, some designs on the roof, and then you can select from there 1 or 2 of those contractors to come out and perform a site assessment. An on-site site assessment is important in solar because without it, your contractor hasn't seen your attic, your electrical panel, nor have they had a chance to measure your roof and take solar readings up there. Without that information, nobody can accurately bid your project or tell you what that system would produce. So if you have somebody who knocks on your door who's trying to get you to sign up for solar, but they haven't taken the time to do their homework, get up in your attic, look on your roof, inspect your electrical panel, please don't sign a contract with them until they've had a site surveyor come out and gather that information. Otherwise, you're just leaving yourself with an open-ended contract where change orders may come into effect in the future. All right, what we have here is a PGE service, and this is called a meter main. It has breakers in it that feed various panels, main panels or sub-panels throughout the house. And so we'll document this by taking some photos of the wall space here, so that when we come out to install it, we've got everything documented and we know what to expect. Part of the solar project, part of what will happen is this meter will be replaced. Not the whole box, just this meter will be swapped out. PGE's metering team, once we have an approved electrical inspection, they're notified and they know they need to come out with a bi-directional meter. So one that's very similar to this, but it's programmed to be bi-directional. It will now not only record what this house is using, but also any excess energy it sends back to the grid. So take the cover off here because we might interconnect here, and we'll get a closer look at that. And then we will go look at the main electrical panel inside of the house. So that's what we're doing right now. In this case, we have some open breaker spots down here in the bottom of the panel that we could use to interconnect solar. I still think it'll probably be better to interconnect at the meter main that's outside, but I'm still going to document this so that we have it. And if our electrician or our electrical designer decide that it is better to interconnect here, we will, and we know exactly what we're looking at. So we're doing a solar assessment today here in Oregon City, and one of the first things we're going to do is go and take a look at the structural elements of the attic, make sure that that roof can support the additional 3 pounds per square foot of solar panels in the racking system. So especially on older homes, we need to go up there and verify the lumber dimensions and the spacing and make sure that there are no surprises. And so that's what I'm doing today. I'm gonna hop up there real quick. It's kind of a hot day, so it's gonna be a little muggy up there, but get the measurements as quick as we can and come back down. All right, so all finished up there. It is this is an older home, so it's a custom-built rafter system, which just means we have to verify and document the size of all the lumber and the spacing on it, which we've done now. We will send it to our engineer just to verify, to see if we need an engineering report on the structure or if it meets what we call the prescriptive path, which just means the structural permit can be easily pulled without doing an engineering report on the roof. So anything that's a pre-engineered truss where the trusses came in on a truck, generally houses built after 1970 will be pre-engineered trusses, but homes that are older than that tend to be custom-built rafter systems where we have to go up and take some careful measurements. So. All right, we're now up on the roof to complete the solar assessment. We've taken a look at the meter main, we've taken a look at the electrical panel. What I have here is the initial estimate. So I originally put together a system design and sent it to the customer. They've taken a look at it. They say, yeah, I want to explore further. What I'm going to do today is verify that the panel layout in the original proposal fits, or if we need to make some modifications, we will. And then probably most importantly, I'm going to take some solar readings from across the roof and develop a shading profile to see basically determined, I've estimated what that system would produce, the proposed one would produce. Now I'm going to verify and recalculate the energy production estimate for the system. And to do that, we use what's called a solmetric sun eye. There are some virtual tools you can use online that use LiDAR and some other fancy ways, but the bottom line is until you get up on a roof with the solmetric sun eye and you take actual solar readings, you don't know exactly how much light hits the surface area. So we always do an on-site assessment to confirm our numbers, and that's what I'm going to do today. This has a fisheye lens. Once I plot in the pitch of the roof and the orientation of the roof, so which way it's facing, 180 degrees being true south, 270 degrees being west, or somewhere in between. I plot in the pitch of the roof and the orientation, and then it's going to take photos, and it knows where the sun is 365 days a year and every hour of the day, and it will determine some of these trees. It'll say, okay, well, at 8 a.m. that tree is shading that particular area of the roof, and it will score lower than another area of the roof, for example. So it's going to take photos and plot in that sun, the path of the sun across the sky, just like Sun Path Services. And it will give us a better idea of solar energy production. I'm also going to measure the roof, make sure that the panels fit the way they're supposed to, and verify any vents, things that we might have to work around when we're actually doing the installation. Make sure we have fire pathways if they're required for code. And that depends on a bunch of factors, but basically we're just up here documenting everything, and so we can get a final bid in the customer's hands so they know exactly what the system costs, exactly what it's going to produce, and what it's going to look like on the roof in terms of panel layout. So let's get started. And so 5 on that side of the vent. We won't end up using all this roof space, but you never know till you get back and look at your solar readings and all your measurements where all the sweet spots are. So we got to document where panels could possibly fit anywhere, and then we'll come back and we'll refine it down and eliminate the worst performing panels, keep the best ones, keeping in mind that aesthetics sometimes come into play. The homeowner wants a certain design or a certain layout, we certainly do that. We sometimes sacrifice a little production just to make the array look better. The more symmetrical we can keep it, the better it's going to be for resale. And just every day, somebody taking a look at it, it's going to look better on the roof. So I've got the measurements on the other sheet, but this is just showing that in total, we're looking at 26 panels that we could do. The original design was for 21. So most likely we're going to end up removing some panels that are lower on the roof and closest to this large cedar tree. And we will be focusing primarily on this side of the roof that gets us away from that tree and our open solar window there between the trees. That's what it's looking like right now. So the other reason we're taking solar readings using this solmetric sun eye is that in addition to verifying what the panels will produce in any given area, the Energy Trust of Oregon and the Oregon Department of Energy both have minimum, what I call solar access requirements. That just means they want to provide incentives and rebates to projects that are viable, that are going to produce a good amount of energy. So if you're trying to put panels on a north-facing roof in this part of the hemisphere, that's generally not a good idea. You're going to have very low production, and the Energy Trust is not going to contribute money to that project. So these solar readings that we're taking actually get sent in as part of the incentive verification project with the Energy Trust. How many solar quotes should you get before you choose a contractor for your solar installation project? We recommend 2, ideally 3. That way you have plenty of equipment options and prices to compare, and it will help educate you to speak with those different contractors and get their opinions and takes on solar and what would be the best fit for your home.